here. We welcome you all for this eventful function. Identifying intellectual property component at the early stage of innovation, IIC of G.And College. Welcome is the attribute of the Indian real intent, has established this nation at the crest of crowning glory. Now we invite Mrs. P. Radhika ma'am, Assistant Professor and Head, PG and Research Department of Chemistry, SSP, to gathering.
Breezy morning to everyone. Small cheer and a great welcome makes here very few. William Shakespeare. I would like to welcome our head of the institution, our respected principal, Dr. P. Balagurusamy, one to chisel our faculties and students in a visionary path. Next, I would like to welcome our chief guest introducer, Dr.A.Pandikumar, Assistant Professor of Chemistry. Then I feel pleasure to welcome our chief guest, who is a vibrant orator, come innovative thinker, and one to guide the budding generation. Dr. A. Pandikumar, signing and convener of IIC, and Mr. Rajmohan, coordinator of IIC. Then I would like to welcome Dr. G.N. Kausalya, head UG Chemistry, aided, Dr. A. Pandirajan, head PG Chemistry, SSP, and all our faculty friends and students to make this program success. Once again, I welcome to all. Thank you.
Thank you, ma'am. Leadership is about making others better as a result of your presence and making sure that impact lost in your absence. I extend my genuine welcome to our respected principal, Dr. B. Balagurusamy sir, principal and IIC President, G.And College, to deliver the presidential address.
Am I audible?
Yes, sir. Yes, sir.
Most respected resource person of this wonderful webinar, Dr. A. Pandikumar, Scientist, Functional Materials Division, Council of Scientific and Industrial Research, Secretary, Central Electrochemical Research Institute, Karaikudi, respected Vice President of IIC, Dr. Ravichandran, respected convener of IIC, Madam Dr. Satyabama, head of the Department of Chemistry, aided courses, Madam Dr. G.N. Kausalya, head of the Department of PG Chemistry, our beloved brother, Thambi, Dr. Pandirajan, SSC UG, head of the department, Madam Radhika, the man who is behind with the principal for this type of innovative activities, Chef Rajmohan, head of the Department of Hotel Management and Catering Science, all other faculty fraternity, especially former principal and one among the well-wisher to the principal, Dr. M.S. Dayalan, my dear participants from various parts of Tamil Nadu, professors, student friends, very good morning to you all. First and foremost, on behalf of our most respected secretary and correspondent line, Dr. K. Rathinam, and our beloved brother, Thambi, Director Durai Rathinam, on my own behalf, I wholeheartedly appreciate the faculty fraternity of both aided and SSP Chemistry for having organized this type of wonderful webinar on identifying intellectual property components at the early stage of innovation in association with our college Innovation Institutions Innovation Council. My dear friends, the formation of the Institutions Innovation Council or the establishment of the council is only to inculcate the entrepreneurship knowledge of our students and to enhance their potentiality to become a very good entrepreneur. This is the prime motto of the formation of institution and innovation cell. To equip the knowledge of the students of not only chemistry, but also for all the students. Today, the faculty fraternity of the chemistry are organizing this wonderful webinar. I wholeheartedly appreciate them. As a president of the Institution and Innovation Council and as a presidential address, I have to touch upon some one or two points regarding the main title of the webinar. Innovation means doing something new that improves a product, process, or service. Many innovations can be protected through intellectual property rights. That is the Karaka mantra of every higher education institutions nowadays, intellectual property rights. Intellectual property serves as the foundation of innovation in our economy. Laws protecting intellectual property also reduce the transaction costs between inventors and industry by providing information about quality of the invention without jeopardizing the ownership of the idea. Intellectual property rights cover the creation of the human mind, which results from human creativity and innovation. It enables people to earn recognition and earn financial benefits and also encourage inventiveness. The invention refers to the occurrence of an idea for a product or a process that has never been made before. Invention applies the implementation of an idea for product or process for the very first time. The smartphone, the car, the desktop computer are some examples for inventions. While innovation is the continual upgrade of inventions. The types of intellectual property rights are patent, trademark, trade secret, geographical indication, copyrights, plant varieties, design, etc. Every startup has IP rights, which it needs to understand and protect for excellence in its business. Every startup uses a trading name, brand, logo, advertisement, inventions, design products, or a website in which possess valuable intellectual property rights. While starting any venture, the startup also needs to confirm that it is in violation of the IP rights of any other person to serve itself from any unwarranted litigation or legal action which can thwart its business activities. With these few words, I once again congratulate the faculty fraternity for their initiatives to organize this type of wonderful webinar. Once again, I appreciate the resource person, Dr.A.Pandikumar, for his accent to be a resource person for this wonderful webinar. Thank you. Thank you, Ananda.
Thank you, sir. Now we invite Dr. M. Pandishwaran, sir, Assistant Professor, Aided Department of Chemistry, G.D. Arts College, to introduce the chief guest.
Good morning to one and all. Good morning to who are present in the online portal. Good morning. I'm happy to introduce today resource person Dr. A. Pandikumar, scientist, Fundamental Materials Division, CSR. He did his BSc and MSc degree in Kandigram Rural University 2004 and 2006. After completing the PG degree, he joined as a PhD in Madurai Kamaraj University. He awarded in 2014. Before joining the CSR institution, previous experience is research assistant, University of Malaysia, December 2013 to June 2014. Postdoctoral research fellow, University of Malaysia, July 2014 to May 2016. Research assistant professor, SRM University, May 2016 to April 2017. And he has awarded more than 15 awards from reputed institution and organization. Award Royal Society of Chemistry from UK, award from 2021. Recognized as the world top 2% scientist in 2021. List done by the Oxford University ACA and Elsevier Group in chemistry category. Recognized as a world top 2% scientist in 2020, a list done by the Oxford University Elsevier Group. He is selected for the expert member in Review College 2020 to evaluate the research proposal in research fundamentals in Belgium. Then he selected for the Royal Society of Chemistry Reviewer Panel member 2020. Early Career Research Award and DST SERP in 2018. Albert Newton Marcus Lifetime Achievement Award 2018 from UK and USA. Biography listed Marcus who in the world 2016 and 2017. He had the award. Outstanding Reviewers Award for 2017 and American and Netherlands from this country. Outstanding Research Award from 2017 from Netherlands. Reviewer Awards from Web of Science. Sentinel Science Award in Chemistry in Web of Science 2016 also. High Impact Research Grant Postdoctoral Research Fellowship Award from Malaysia. CSR Senior Research Fellowship from our CSR Delhi. UGC JR Meritorious Fellow from New Delhi in 2010. He research interested in design and fabrication of functional materials, interfacial engineering and sensorized solar cells, photocatalytic and environmental remediation, and photocatalyst for solar fuels, two-dimensional layered material for electrochemical sensors. He completed the two major research projects, one from DST and SERP, another one CSR and SICRI. Now is 3 ongoing projects from DST and CSR from huge amount. One project is around 47 lakhs, another project is 20 lakhs, one more project is 38 lakhs. Now his research and guidance and ongoing 5 PhD students and 2 postdoctoral research work, 1 PhD is awarded. Research publication is on total number of publication 134, review papers 10, review research papers 124, edited books 16, book chapter 5. Total number of citation is 4,494. H index is 39. Google Scholar, based on the Google Scholar database. Invited lecturer 57 invited. Talking is always busy scheduled in his academician. Another, he is a professional activity in full-time member in American Nanoscience membership. Editor in Advanced Journal of Physical Science, assistant editor in International Journal of Research in Engineering and Technology, referee in Royal Chemical Society, Chemical Communication, Nanoscale, New Journal of Chemistry, Physical, Chemical, Physics, Journal of Power Sources, Journal of Hazardous Materials, Scientific Reports, American Chemical Society Nano, American Chemical Society Applied Nano Material and Interface, Solar Cells, Ceramics, International Vibration Spectroscopy, and Applied Surface Science. International expert in post-tractor in Belgium, facilitator in Malaysia, organizing committee in Malaysia, organizing committee in one-day national symposium and recent development in chemistry in 2016, Madurai Kamaraj University, technical chair in international conference on advanced nanomaterial and multifunctional applications, Malaysia, coordinator in international conference on recent advances in medical material chemistry, SRM University, organizing committee member in Asia Sono Chemical Society Conference 2017, co-convener in school and hands-on training of photovoltaic for solar energy harvesting, SICRI, international expert in Iran National Science of Fundamental in Iran. I'm really happy as a very energetic and young and energetic person today, research person as Dr.A.Pandikumar. Welcome you, sir. Thank you, one and all. Give me the opportunity for the introduce the today's chief guest. Thank you.
Thank you, sir. Next, I would like to invite our chief guest, Dr. A.Pandikumar, sir, scientist, Functional Material Division, CSIR, Central Electrochemical Research Institute, Karaikudi, to start the session, sir.
Thank you, ma'am. Good afternoon to one and all present here. Respected principal, convener, faculty members, budding scientists, warm good afternoon to all of you. So today I am going to talk about the intellectual property rights and how we can protect our innovation to make profit, as well as in the efficient way how we can avoid the piracy and also avoid the copying from other people. So for that, I'm going to talk about another 1 hour regarding this intellectual property component and its early stage of innovations. So this one I will proceed with. Initially, I will start with some of the innovation what we have done in our laboratory. So how we have protected this innovation through this intellectual property rights or obtaining the patent or copyright. Okay. So I request the organizer to enable to present me. Kindly enable the option for the present.
Just a minute, sir.
PPT. Okay.
Now it is enabled, sir.
Not yet, ma'am.
Sir, please check now, sir.
Yes. Now it's fine.
Okay, sir.
So today I'm going to talk about identify the intellectual property component at the early stage of innovation. So why we have to worry about this intellectual property rights and why we have to protect the innovations? Why? Because you are creating some idea or you are making some product. So the other people simply they take the recipe of this product, then they will duplicate and sell it in market. To avoid such a kind of duplication or the previously, the DVD. So if any movies come immediately, they will make a piracy video, then they will sell it. or else nowadays they are telecasting that internet, they are hosting in the internet. So because of that, the huge loss for that producers. So for that, they make that a copyright. So that means if you are without permission, if you are using those material, it will be punishable offense. For that, you have to create a copyright. So those kind of protection that will be comes under this intellectual property rights. Okay. So with this, let me introduce myself. So actually, I am talking from Karaikudi. So the Karaikudi is located in between Trichapalli, Madurai, and Rameswaram. So the Karaikudi is the middle of these three historical place. Especially the Karaikudi also is called as a Chettinad. So the Chettinad itself, the geographical identification. So that Chettinad itself, you want to use it for some other place, you have to obtain the permission. So that's why, for example, people will call this Madurai Malli, Dindikal Puttu, Palani Panjamirdam, Tirupati Laddu. So likewise, if a product is available in certain place, then that particular place will be identified as the location. So the product name is called along with that geographical location. So that itself that is protected. So you cannot use that the Tirunelveli Alva instead of Dindikal Alva. You cannot simply call. So the Tirunelveli Alva is that kind of geographical identification. So we have to register such a kind of material. Otherwise, the other people will make that copyright. So this is our institute annexed building. So here all the facilities like what are the cutting edge research you want to do it, all the analytical facilities are available in this building. This institute is established to mark our independence. So after we got the independence, Pandit Jawaharlal Nehru, he want to establish several national laboratory to increase our economic growth. For that, he planned to establish several national laboratory. So this Central Electrochemical Research Institute is 11th national laboratory. So while he decided to establish this laboratory, so Vallal Alagappa Chettiar, he approached Pandit Jawaharlal Nehru. He offered 15 lakhs rupees and 300-acre land during that 1948 itself to establish this laboratory. Because of his effort, this CSIR Central Electrochemical Research Institute is established in this remote place. The Karaikudi, the time is the remote place. So this is the inauguration ceremony. So here you can see that Sandhi Swarup Patnagar, then Sachivi Raman, Alagappa Chettiar, all are present over this function. This is the inauguration function of SICRI. So our CSIR SICRI offer a final year project for that BTech students and MSc, MPhil student. So if a student wish to do their final year project, they can do it in our CSIR SICRI. The budding scientists are most welcome to do their final year project and learn new things. Also, we are having that n number of sophisticated analytical facility. So the faculty members and research scholars may visit this website and make utilize our facility. Also, we are offered the PhD program under ACSIR. Also, we are having the specialized course. This particular course only available in the SICRI around the India. So if you visit in India at any place, you cannot find the particular course. That is the chemical and electrochemical engineering. It comes under Anna University. So this is our main entrance. So our core research activity is somewhat related to electrochemistry. So for that, we are working on corrosion and material protection, electroplating, metal finishing, electrochemical power sources, electroorganic and inorganic, electrodics and electrocatalysis, electrochemical material science, functional materials, and pollution control. So actually here we are working in 3 different ways. So the fundamental research and the applied research, then technology-oriented research, then the commercialization research. Actually, we are in a different category of research. For example, the fundamental research is mainly involved. We will do some studies, then we will come out with some interesting result. That result will be published in paper. So we are documented. So in that way, we are protecting our innovation. So if you publish in paper means this is invented by this particular scientist. So in that way, you can protect your findings. The next one is applied research. Applied research, we call it as, for example, I have done something, then I have published the paper. Then I have to bring this fundamental research to applied research by making a small proof of concept or prototype device. So this is means this is applied research. So this is also we can make that a pattern. Okay. So the pattern we have to make that a claim like this is the innovation. So this is the methodology. So this is what we got the findings. So in that way we have to make that a claim to protect these findings. Then the next level is that proof of concept to scale up process. So in the scale up process, we call it as a FTT, the fast track translation project. That means they will provide the short period of time, especially they will give for 1.5 years or 2 years to come out with the technology or product. So in that case, the project will be approved once you have proved that proof of concept. Okay. For example, you are walking the road, you find something, so that is innovation. Okay, so the same thing if you may make it in the next level. Okay, so same thing, they make it in the next level and proved to your neighbor. So you are showing some device, so I have made this device. So that is that proof of concept. Once you reach this proof of concept or prototype, the smaller size device, then you can apply for FTT project. So after obtaining the patent, you can apply for FTT project. So this FTT project, that will be it's that verge of commercialization. It's not completely commercialized, but it ready to commercialize. So that case, you have at least to show that proof of concept. I have achieved the proof of concept, or I have the prototype device. For example, you are synthesizing some chemicals. You are able to do that. I can synthesize per day 5 grams of particular chemical. Then this will be fine. For example, you are having that organic lab. Then organic lab, you have to prepare some derivatives. The derivatives may be in milligram. Okay, so that will be a fundamental level. Then if you are come out with the 5 grams, that will be applied level. But you per day you want to make it 1 kilogram. So that is, we call it as a fast track translation project. So in that case, what we will do, the reactor setup or the device size, that will be larger. But the target is what are the results you have achieved with that smaller size device or that 5 gram of chemical. The same property, the same performance should be if you are preparing in 1 kilogram. Okay, so for that you have to make it. So this is the next level. Okay, so in that case, they will provide the short span of time. You have to solve the process. Now you have to maintain the property, and you have to make it in a better way to reach the goals. So in that case, you will get the product. So the product property, we have to compare with this one. Then you have to file the patent. So in that way, you have to protect this one. Then later you can go to that FTC level. FTC level, it's nothing but you have to work on that, how many manpower involved, how many hours it required, how much the reactor cost, everything we will work out. Then after that, we will fix the rate per kilogram, this much rupees. Okay, then we will sell it the technology to industry. Then for that selling the technology, we will get the royalty. So that technology, it's only available for that particular year. For example, 5 years, the industry can use our technology for 5 years to produce this chemical. Likewise, you may ask that question, how you are providing the technology for 5 years to that particular company, but other people, they cannot use that particular technology. So they should not disclose that particular technology to other people. They have to produce only their own product by using our technology. So in that case, there is another restriction. Okay, sir, maybe they can use for 5 years. After that, they don't want the technology, no need to pay the royalty. But in that 5 year, they can produce what are the demand record for that next 20 year, 15 year. Then in that way, what they can do it. You may ask, but while we are transferring the technology, per annum, you have to produce this much tons of particular chemical. You should not produce more than particular tons of chemical. Once you violate, it will be punishable offense. If you are violating, for example, per year 1 ton you have to produce, per year 5 ton you can make it. But you are violating the agreement, then if you are going with more than that, so what happened? It will be punishable offense. You can send a notice through court, then you will get that compensation or a penalty to that particular industry. So in that way, you can protect your innovations. Then you can make a profit. So 5 years they can produce this much. Then accordingly, per kilogram, if you are producing, then 20% royalty should be sent to our innovators. Okay, so for example, 1 kilogram will be 100 rupees. Okay, if you produce 1 kilogram, then the cost will be 100 rupees. In the 100 rupees, 20 rupees should be paid to that innovator. Okay, who is invented that particular product. So in that way, they have to pay the royalty. If you are producing 1000 kg, then you can multiply the 20 into 1000. So likewise, you can pay that royalty. After 5 years, still you are producing the same thing, then it will be penalty that will goes to that multiples of 1000. Okay, so you have to pay a huge amount of money. For example, some few years ago, the Samsung, they introduced one mobile phone, so that will mimicking the structure of iPhone. Okay, so the patterns and other appearance, then icon, everything that will resembles the Apple. But the Apple, they have created that copyright, so they cannot, other people cannot use or they cannot copy. So for that they filed the complaint. Then they got that compensation from the Samsung for several $1 billion just a few years ago. So this is the case. So likewise, you cannot exactly copy that other ideas or other product or recipe. Why? Actually, if you see that the KFC chicken, so the KFC chicken, it's started in abroad, but you just see this in India, it's several outlets, you can see that the KFC chicken. So this means the companies directly, they are investing in India and they have started the franchise like that. It's not like that. They will give the recipe, so they put their own name, but the local investor, they will get the recipe, then they will do it. For that, they have to pay certain amount. So it will be local made, but they are selling in the name of KFC. So that's why the recipes, so the trade secret, the recipe means that is a secret. So they won't disclose to others. So this is what the intellectual property that can be protected. Okay, so let me go further. Actually, our group is mainly working on the solar energy materials research lab. Especially we are working on functional materials. So whenever we are preparing some material, we will explore their properties. Then we use the application in like a solar cell or a sensor device or hydrogen production or CO2 conversion. We will explore it. Then if the result is good, then we will go with the publication. So that is one way of protecting our innovation. So we are the first man, we did this one. So for that, we are publishing our finding in the research paper. So this is one way of claiming our innovation. So suppose I am having that excellent performance and maybe it is totally new, then I will file the patent. So the patent that may be either on the material processing. So how we are preparing this material, the material processing, maybe we will file the patent. Sometimes the hydrogen production performance is good, or by the electricity production is good, then we will go with that, the device part. We will file a patent over that, this device structure. So how we are fabricating the device, how we can explore the device, how we can find the efficiency of the device. So those secret, everything we will make it as a patent. So this is the another one. Suppose it is economically viable process and feasible for that scale up, then we will transfer this technology to other industry by making that MOU. So that means they can use our technology, then they can produce n number of solar cells, then sell it in the market. That technology transfer will be two types. So you want to fabricate 1,000 cells, in it will be on commission basis. We normally call it, don't call us a commission. It is the other term, because this will be involved in that transfer of innovation to others. So that means we call it as a name royalty. Okay. So other thing, excuse me. Hello. Hello. Bojan phone பண்ணுப்பா. So in this way, we can transfer the technology and we will get royalty on that particular period. Otherwise, the lifetime transfer, that means one-time settlement. The company will settle certain amount to us to get this technology. For example, 1 crore they will provide us as a compensation to use the technology. After that, this technology we cannot sell it to others, and also we should not use that particular technology. So this is what we will transfer the technology. So this is a one way of protection. So why? Because once we transfer the technology, that particular company is the monopoly to sell that particular material in the market. Okay, so you cannot buy from others. So what are the rate they want to fix it, they can fix it, and if they want, they can create the demand, and they may raise the price. That will be, it depends on the company. But if it is based on royalty, they cannot make the demand and other things. So ourselves, we can make that particular technology is available to others. So that also is possible. So in that way, we will start with the material and the processing and come out with the application. So actually, this is my research team. So they are my pillars. They are working on the solar cell and hydrogen production and CO2 conversion. They are involved in different projects, especially this guy and this guy, this girl. They are all belongs to that Dindikal only. They graduated from Gandhigram University. So this girl is belong to Chinnalapatti. Okay, so I'm also my native is Dindikal only. So that's why I'm much interested to take that rural background students. So if you are having, if you are able to clear that gate or net, so definitely I have a position for you to do the PhD or you do that research in my research lab. So this is our funding agency. So this funding agency is offered several projects to develop several materials in our lab. So we are having that international collaboration in US, UK, Malaysia, Singapore, China, Taiwan. So these are the materials we have developed, and few materials we have published in that paper, and we have done pattern on the selected material. Why? Because these materials have the best performing material. So this is having the benchmark efficiency in that application, like solar cell or hydrogen production. So in that way, so these material synthesis methods, so we have filed the patent by using what are the precursor we are using for that. So while we are filing the patent, so we have to give all the details, like so what are the precursor we are using, and what is the temperature, what is the reactor type, then what is the temperature we are maintaining, how much volume we are taking, so how much time we are allowing for that making the reaction, and how much time we are sparing for that this material pre-treatment, everything. Then finally, how much the scale, for example, whether this particular hierarchical morphology that will appear in only milligram or gram scale. It's very tough preparing the nanomaterial in that gram scale. It's very tough. So likewise, we have started with the microgram, then milligram, then we have end up with the gram scale. So even though if you are coming with a large quantity of sample preparation, that structure and the property should be maintained. So we will provide those information in that pattern, then we will submit to our office for the approval. So later you have to file that provisional patent first. If you start the experiment and you are getting some initial result, once it is everything is came, then you have to provide all the details. Then if you wish, you want to file Indian patent, or you want to go for abroad for patent, then you can do it. So that is the next thing. So whenever you are doing patent, you have to disclose all the things. Then if the people will search the patent then the ideas, if they like, then they will contact you. Then they will say that we are interested in this patent, we want to develop certain material or certain application, so we are plan to use your methodology. Then okay, then you have to tell that how long, you have to ask how long they want to use that patent, how long and how much quantity they want to produce. So those information, everything you have to collect it. Then you have to sign an agreement, and you can transfer the technology to those persons. Okay, so in that way we are developed several materials for the solar energy conversion. Okay, so why we are working on this solar energy material? So I will just give some glimpse, then later how we can come out with the product, then how we can make it this into the commercial, how we transfer the technology to that company. So I will tell you. So this is the surveys taken between that January and December. So this survey is clearly giving the details about the sold out electrical vehicle. Why? Because the government they want to stop that diesel or petrol vehicle, and they are canvassing to switch over to that electrical vehicle. So this is worldwide so sold out that electrical vehicle. If you see the Tesla Model 3, that is 3,65,240 vehicles are sold out. Likewise, there is a different Hyundai, Volkswagen, Nissan. So several brands are there. So all the companies are there selling that electrical vehicle. Why? Because you just see this the electrical vehicle that have that charging point. You just it's like charging our mobile phone. So you just to put that plug in that charger, then you can charge the vehicle. So the charge will be stored in the battery. So the battery will operate the vehicle, so it will not emit the carbon dioxide. So this is the idea. So likewise, the government also, they are canvassing and they are setting the target to produce several electrical vehicles. It's like e-bike and e-scooter, auto, then car. So the government, they are making canvas to switch over the fossil fuel based vehicle to electrical vehicle. So for that, they are providing, you want to drive the electrical bike, no need a license. Likewise, you are supposed to purchase this electrical vehicle, you will get a tax exemption, then no need to pay the road tax, and you will get some incentive. If you are a government servant, you will get some incentive to use this electrical vehicle every month. So likewise, governments are announcing the different scheme. So they think that if we are using this electrical vehicle, we will not use petrol or diesel, then we can control the petrol price, as well as we can save the environment without polluting or emitting the carbon dioxide. Why? Because the carbon dioxide is carcinogenic to the human being, especially it will emit and it produce greenhouse effect, as leads to global warming, that leads to climate change. For example, some 5-6 years ago and all, if we see that December or January, it is a winter season, so you can see a lot of pani. Okay, so that means previously the climate like this. So once if the Diwali came, then the raining season is slowly going to stop. After that, there is no rain. But now still in January it's raining. That means due to that climate change caused by that emission of carbon dioxide. Okay, so this is the right time to switch over from the fossil fuel based vehicles to the electrical vehicles. So this is the good approach. The government also thinking the same. But what it's really happened, you just look at this. This is the electrical car. This is run by this is charged by diesel generator. So that means even though you are using that battery vehicle, but the electricity is again produced by burning the diesel. So that means it's not 100% green. So we have to think that, find alternative strategies. So for that, also you just look at this, the energy reserves only this much, the coal, uranium, oil, gas, these are all natural resources. So this is available very little. If we keep on explore it, then it will be exhaust soon. After that, you won't get any energy. Then you have to find the alternative energy source. The alternative energy source, that is renewable energy source, the wind power, biomass, hydropower, waves, tides, and the solar power. So these are all alternative energy source. We have to utilize this solar energy. So that will be the promising one. Then the hydrogen also is a very good solar fuel. Why? Because it has that high energy density and high conversion efficiency. It is produced from water and it is earth abundant, so you can easily store in different forms. So that's why we call it as the hydrogen is the alternative fuel to that petrol or diesel. So how will this hydrogen can be next green fuel? Let me see. Actually, I just skipped this slide. I don't want to discuss. Okay, now we have to come to that original story. So just to look at this, this is the train. So this train is the electrical train. That is zero emission vehicles. That means it will not pollute the environment. It is 100% run from that water. You people may be here that some people are running the bike or bus car by using the water. Maybe you can ask. It's not just joking things. It's realistic. If you have the water, you can drive the train or car. So this is the train is invented in Germany. So this is the car in Japan, Toyota company. So this is the bus is invented in US. So this is the truck is introduced in that South Korea. So these innovations. So these innovations, how they are going to protect. So this is the important thing. So how that intellectual property rights that may be help. Okay. So that is the most important thing. So you just think that the people maybe simply tell that if someone asks, please give your bike, I want to go to somewhere and come, then you may ask that, the petrol prices are very high. It's not like a putting water and go, but now it is feasible. You just take water, then you can drive wherever you want. Okay, so that is the technology advancement. Okay, so I will show that how this electrical vehicle that can be run from that water. So you just look at this. You just take the water, break into hydrogen, and store the hydrogen into the hydrogen storage station. Then you just leave the oxygen to the environment. Then you have that fuel cell vehicle, so that has that hydrogen storage tank. You fill the hydrogen here, then you take that fuel cell stack, then that is boost converter and the power control unit, electrical motor, and there is a membrane to allow that oxygen. Okay, so here you are taking water, break into hydrogen and oxygen, then the hydrogen is fed here. While we are running that vehicle, the oxygen is passed from that environment and reaches the fuel cell, and the hydrogen is from the tank that will reach the fuel cell. Okay, so in that case, what happened? The hydrogen and the oxygen is combined together. It produces water. So this is basic chemical equation. As a result, it produces the electricity. Okay, so that electricity is used to run this vehicle. So before that, the battery operated vehicle, you have to produce electricity separately, then you have to charge it. But suppose now you are having the water. See here, the water that can be splitted into hydrogen. That hydrogen can be used in this car. That can be combined with water, oxygen, and produced water. So the byproduct here is the water. So you are taking a water, producing the electricity, and again the water can be formed. So it is a cycle. So this is what this fuel cell car is works. I will show a small video how we can generate the electricity by using this hydrogen technology. So as already told, it's a very simple chemical equation. Hydrogen in combination with oxygen, it produces electricity, and the byproduct is the water. So based on that, this technology is developed. So this is the hydrogen storage tank, battery, fuel cell stack, a boost converter, electric motor, power control unit. So now you see the hydrogen from the storage tank, it's reached the fuel cell, the oxygen is reaching here, it produces electricity, the part of the electricity is stored in battery. So the fuel cell that will generate electricity, that will pass it to parts electricity stored in battery, and the remaining electricity is used to drive the car. Okay, so in that case, what happened? Whenever you are driving with one person, you need a less amount of energy, or you are driving in the flat area, you need a less amount of energy. You want to go to the hill station, you need additional energy. So that time the battery will supply additional energy. Then you can smoothly drive the vehicle. So let me see how this fuel cell that can be produced electricity. So this is the membrane. One side is the catalyst, another side is another catalyst. Both is coated negative electrode and positive electrode. The hydrogen is coming from one side, oxygen is coming from one side. So both will combine together, it produce electricity, and the byproduct is the water. So in that way, we are producing this one. But accordingly, we have developed that technology. Okay, so this is what we can use this hydrogen as a fuel for drive the vehicle and to fill the objective of this electrical vehicle. Okay, so you just look at this. What are the things you have seen where you have produced that electricity? So that is called a fuel cell. So this is the fuel cell we have developed from the Sikri. So recently. This is that zero emission fuel cell bus is launched. The technology is transferred to Sentient Labs company. So they have that facility for that building the body and the mechanical part, other things. So mainly we have developed this fuel cell stack and installed here. So previously you just look at this electrical vehicle that is run from the water. So that is the big dream when we are going to get such a kind of technology. So we are proud to say that we have also developed this fuel cell stack, and finally we developed this zero emission fuel cell bus. So this is our technology. So we have prepared this fuel cell stack, and we have designed the thing, manufactured and assembled and validated and certified, and now it's dedicated to the government. So soon it is going to be used for that local transport, especially like the New Delhi, Mumbai, West Bengal, Chennai. So such a kind of major cities, it's soon it is going to be launched. Okay, so here we have protected our innovations, like making component wise. So for example, if I want to file that patent, so here how much bolt, nut and other things we are using, so how many stacks of membrane we are using, so how we are preparing this structure, why it is a rectangular, why not it is a square shape, why not it is a round shape. So that means so that structure itself we will protect with this one through that intellectual property rights. Okay, so I just saw that this is the launch of our Sikri developed bus, zero emission bus. So now our in India also we have achieved such a kind of things, but you have to remember one thing. Actually, the other countries, they have developed this zero emission vehicle by importing the components from that abroad. Then they assemble together. Then finally they developed the things. But here we have developed this zero emission bus is based on availability. What are the raw materials available in India? So it is 100% indigenously developed. The design, manufacturing, assembling, validation, certification, everything within the country. So we didn't depends on the other country for developing this technology. Okay, so Okay, there is some drawback, like storage of this hydrogen is somewhat important. So it has that risk. If any accident happens, there is a possibility for firing. But now mm, we have that the better storage facility, especially by making different layer for protecting, and it's prevent from the fire. Then the Honda has done that safety test, so it is passed. So it not get exploded during the accident. Okay, so these are the other side. Okay, I just skip these things. Okay, so now we have the technology. So we have done that innovation, created idea, concept, proof of concept, and finally we have done that product by validating the other factor, everything. So now we have to go for business. So now the intellectual properties for business series, let me see that. So actually we have to making into a different way. So first we have to making the mark, that is trademark. If you see any of the logo, the top, you may see that T and they make it circle. So that and all trademarks, then the designs, and sometime investing the future. For example, you can put this methodology, everything as a pattern. Then if someone is see the pattern, they may interest, they may be pay some money, then they will use our innovation. So that is another type. Okay, so let me come. So as already told, we have started with the basic research. So we will start with hydrogen evolution reaction. Then we have used that hydrogen into that fuel cell. Then we come out with that the fuel cell able to produce electricity. So that is the invention. Then later we have developed that component. Then finally it comes to the production. Now it's ready for marketing. So that bus, we have started with the basic research, applied research, invention, development, protection, and marketing. So this is way we have to protect our intellectuals. Okay, so our idea and the creature, everything. So the innovation. So the innovation is that starts from that idea or concept. For you are thinking something new, then it should be evaluated and refined, then developed before it is applied or acted upon. So that is the most important thing. Then the innovation may be inspired by reality. So you may propose something, but it is practically feasible. So that is the most important thing. So for that, the research development. So the research is nothing but the fundamental research. Then the development is that as already told, scaling up, or it will be large quantity or prototype device. Then the production is that the FTC level, the marketing, sales, and other things and all. These are all completely it's to involve money. So here first 3 stage it will involve that research. The next 3 stage it involves that money. So this is what it's most important thing for making the copyright or intellectual property management or patent, whatever that may be. So now we'll just look at this, the improved product or development. So for example, if you see that a mobile phone, the first generation mobile phone is the Nokia or Samsung, that will the big size, that is the button phone. Even you cannot have a camera or FM, whatever it may be. Then people try to improve that product because of that market competition. If you go to that market, you can see the number of companies they are selling the mobile. So you have to withstand in that competitive market. For that, you have to upgrade your existing product. So that is improved product development. Or else you have to launch a new product. So in that way, you can make it. So for that, how we can make it? You can generate idea, then you screening the idea, then the concept development and testing. So what is the concept development? You are having that old Nokia phone, then you just imagine that we can add one FM, or you can insert one SD card, then record songs you can hear. So likewise, the concept development, then the business analysis. If we launch this product, whether it will be give a good breaking in that market, then whether we will get that huge profit. So they will see. Then the technical implementation, then finally they will do the commercialization, then they will launch in the market. So in that way, you have to develop at the earliest stage of your innovations. Then competition and cooperation in the today economy. As already told, you are having that good product, so that you can withstand in that market. You can make more number of what is called a profit. So in that ways, you can consider the property. That is, property means rights, whether you can have the rights to sell it, or you can have that share in that particular company's technology, or you are having that intellectual property. Likewise, several factors that will involve. Then, as already told, the ideas, creativity, and innovation. You just look at this idea, that is creativity. The creativity is nothing but you are having that idea, then you are working on that idea. Okay, so that is creativity. Then innovation, you can say that the creativity and the productivity. You are creating idea, then that should be come out with the product. That is innovation. Other way, you can say that the idea, then you have to work, then you have to come out with the product. So the in other way also you can say that. So the innovation should be something new, totally new. Creativity, you can provide the existing component with the updated one. Excuse me. Hello. Hello. சரி தேட்டில் கொடுத்துரும். ஆமாம். Okay, so that is the innovation is totally new. Okay, so in that way. So now idea to product. So as already told, you have several setup, like you have to start with the idea, then find the invention and come out with the innovation, that is technology or non-technology. Then finally you have to discuss the partner, or if you are having the source, you can convert this technology to product. So this is the one kind of things. So here you are converting idea to product. Then idea to market, that means you are having the idea, then you have to create the expression, then come out with the product, then you have to make it market. So that you have to do the market survey. So in that way, better way you can do it. Then idea to profit. So this is the business model. So you have to search that intellectual property or business model. Then you identify the product. Then that means this product can be most selling in that market. Then you have to get the technology. Then you do the marketing. Then you finally you come out with the profit. So in that way, you have to buy that intellectual property. Likewise, you buy several patents. You can make a product. Then you can sell it in the market to make the profit. So that is the big the important thing. So something you want to use it for your own, so that you can. Or licensing means you are having the new things, then you have to register. Franchising is nothing but it's like a KFC, McDonald's, Mary Brown. So such a kind of a restaurant, like Talapa. If you see that Talapagatti hotel in Dindikal, but if you see outlet in that overseas, that means it's their franchising. So in that way you can make it. How that a pattern can be done. So you just look at this. So the Coca-Cola, they have get a license from that innovator to open that Red Bull cans. Okay, so for that they get the royalty of 1,48 UK pounds a day on this one. So that means this particular design, it is a copyrighted one. So if other people, it will be, the penalty will be there. Okay, so this is what you have to protect your innovations. So you are having the idea, you are having the design. So that particular design someone want to use, you have to do it. Why the shirt have that brand? So the for example, Alan Sole, so several brand Ramraj Cotton. So they are have that different colors and particular design. So that if one company have one particular design, another company may not produce that particular design. So in that way, they have made that a pattern. So the trade secret, as already told, that the trade secret is nothing but some recipe, or suppose you are developing some software that decoding. So these things are trade secret. You should not disclose to others. So that is most important thing. So this is the case study. So one person, they leaked that trade secret, like some software coding to that public. For that they filed that case. Then they have arrested during that 2002. Excuse me. Hello. Sorry. Okay. So the IP rights, that is the copyrights. So this is a it can be easily shared. So it is applicable to that books, newspaper, computer program, database, films, music composition. So these kind of things. So this means it no need a registration, but you want to use it, or for book means you want to make a photocopy or other things. You have to get that copyright permission, then you can use it. So this is what their ideas can be protected. Okay, so I just skip. So this is that some of the example. You are have that some music, songs, or movie. So whatever it may be. So those things and all you can do that copyright work. Then in that way your idea will be more secure. Then you can protect your ideas. So the trademark, so for example, the Coca-Cola company now selling throughout the world, but it seems the particular company is not have that original factory here, but the local people, they will establish industry, then they will use the recipe and they use that design. So they are the labor for the particular company. So that means they have used this trademark for that marketing purpose. So likewise, the shoes brand Adidas, Reebok, Levi. So they don't have factory. They don't have own factory. They have that. They will do that outsourcing. Then ask to put their brand. Okay, so in that way they are producing that product and sell it in the market. So that is the due to that trademark, logo, these things and all. That means they don't have the factory or don't have the company, but they have that technology. They will ask to prepare that particular technology to that product. Okay. So at this stage, I just stop to that due to that lack of time. Thank you.
Thank you, Dr.A.Pandikumar sir. We privilege the session very much, you as a resource person. And we are so much impressed to show the video of fuel car cell and its working mechanism. And we are heartfully appreciated the great work of fuel cell bus. Thank you, sir. Once again, I thanking you.
Thank you, ma'am.
A person indebtedness is not virtue, but repayment is virtue. Begins when the person dedicated himself actively to job of gratitude. Now, I request Dr. J. Satyabama ma'am, Associate Professor, Dean, Ada Department of Chemistry, Convener of IIC, to propose the vote of thanks.
Good afternoon to all. First of all, I thank our management for providing opportunity to organize this webinar. I thank our principal, Dr. Balaguru Swami, President of IIC, for his support and presidential address. I thank our chief guest, Dr. A.Pandikumar, Scientist, Functional Materials Division, CSIR, Central Electrochemical Research Institute, Karaikudi, for his nice presentation and valuable suggestions regarding solar cells, fuel cell vehicles, zero emission bus, and intellectual property rights. Thank you, sir. I thank our Vice President, Dr. P. Ravichandran, Head of the Department of Economics. I thank Mr. Rajmohan, HOD of HMNCS, for his coordination. I extend my thanks to Head of the Department of Chemistry, Dr. Kausalya, Pandiswaran, Radhika, Mrs. Vanitha, Dr. Pandirajan, HOD of PG Chemistry, and all other staff members and students who have participated in this webinar. I have to thank our technical team for arranging this webinar. Thank you, one and all. Thank you.